Hi.
Good. Someone need to come in. Let me let that in. So I guess this is, as you know, this is my last chance to talk to you because next class will be yours, right? And then after that will be the final exam. So this is my last class. Although it is not in the final exam for this class material, but nevertheless, I think this part is the very important if you really want to make a informed business decision, right? Because what we study in the machine learning or the regression does not immediately tell you whether cause and effect, right? It's mainly for prediction purpose, right? Because it's a machine decide how they're related and which one is the best, right? But it doesn't give you a very good idea of whether doing this would help or not, right? Because you are IT manager, you want to implement certain changes to the system or the interface or whatever, then you really want cause and effect, right? Because prediction only mean association, right? It's just not really just help with prediction, but it's not really telling you that if you do these changes, this will lead to that, right? It's not that idea, right? So you want to make the business decision, you want to make changes, then the machine learning can't help by themselves, the technique, right? You really need to understand what should be there, what shouldn't be there, right? There still need something human to decide. Of course, you just need some theory to understand what should be there and what shouldn't be there. So that is the main idea we want to go on to lesson 9 and lesson 10, okay? And but before we continue, I think it's good to review, what we have done in the first 8 chapters and then give sort of foundation because we finished everything there. I supposed to release assignment 3 yesterday, but there's a typhoon, then I have to take care of the kids, so I can't really finalize the homework 3, but the homework 3 will be due, after the exam, that's fine. Because that's asking to do the coding for the machine learning, but you can do it while you prepare the exam, but it's not essential, so I think everything is already in the slide, so you don't really need me to release you the answer before we have the exam. But I think it's good to have a very quick review, I guess, based on our course outline, and then we'll see what are the things that is important, right? So basically, if you remember, the exam is up to, the thing is covered up to the week 8 there, 9 and 10 is we cover today. So the overall goal, right, of this class is trying to give you the very brief overview on how to use statistics in business decision, right? And the first chapter is talking about, the most important thing which we often miss, and it's very important, is how you get your data and how to clean the data, right? How to assign missing value, right? And how to handle them, and these are very important. And you have the good data practice is so important that I can't emphasize more, and but I don't have time to go into very detail because you have to learning by doing. That is very important. And the second one is like you do learn it in the undergraduate where you learn how to handle data, right? To get some idea of what it looks like, right? Look at the bar chart, pie chart, histogram, box plot, scatter plot, right? And all the mean, variance, median, all the analysis of those. That would be a good idea to guide you what's going on, right? When you run the regression, do you want a square term? Do you need the interaction? And these are important ideas when you run regression, right? Or do we need machine learning technique, right? These are very important, right? To understand what's going on there. And then chapter 3 is a classical statistical analysis approach, right? Where you don't want to build a model, but you just really want to use data, right, in the simplest way, right? You do some estimation, you do some hypothesizing, right? The estimation, you have learned point estimate, right? You also learn how to do interval estimate, right? And then hypothesizing, right, it is the way that you see whether the data can support what you think about what's happening in the real world, right? These are the basic tools, right? Up to week 1, 2, 3 is basically what you learn in undergrad, right? There's nothing new there, right? If you learn the basic class and statistics, right? And 4 and 5 are the regression, right? And I think that is the major thing that you would be working, right? I mean, I think we also learn the undergrad as well, right? But the thing is, right, everything implemented in Python in our class, right? You learn how to handle those code, right? And that would be very important, in particular this kind of graph that I don't think you usually draw in undergrad, right? Where like this type of graph that, maybe this type of graph, right? You would, say this type of graph, right? You would do in the diagram, right? Where the red is a regression line, right? This gives you point estimate, right? And it's not really talked too much in the undergrad, or you don't emphasize actually, it's not just a line, right? It's also more important about the interval, right? Because this gives you the best guess, but you have to see how big the bandwidth is to understand what is the estimate, right? I mean, that is actually what happened, right? And that's what happened when we see the, when we have the, actually we often see all the time, right? I think right, I think this is what we have been. I think we have that all the time, right? So like this is the style, right? I guess, can we, no, cannot check this out. Right, you will see that this is the typhoon graph, right? This line is the mean, right? And the bandwidth is very important, right? Because it tells you what you should do, right? And then you do remember your IT manager, right? You have to prepare for worst case scenario, right? And that's what the stress test is, right? It's like you really looking at the worst case scenario, you don't prepare for the mean, right? The risk management, right? That is the main idea, right? Why you need those. And then we will brief go through the probability model about probability and logic. But as I said, probability and logic are not included in your exam. But I just tell you what can be done when you have a y variable 0 to 1. I think I just maybe ask you 1 or 2 questions in multiple choice, but not really. You don't need to know the detail, but just for this chapter, it will be just you just really need to understand the basics. I think that would be the thing. I mean, I think this year I put a lot of emphasis on prediction compared to last year. If you compare this year's material to last year's material, if you have, is chapter 7, 8. That is the main thing that we cover, right? And we learn how to do prediction, right? Look at compare different model, right? Using the trained data and test data, right? Using the cost validation method, right? And based on, say, AIC, BIC, adjust R square, right? Or RMSE to determine which model with the best, right? Do note that when we compare, we are basically comparing horse racing, is comparing predictability, right? Not really telling you which one is reasonable or not, right? So, but say random forest, right? In that case, right, will be something like there's some model there. We combine different model, but we don't. It's a black box, right? We don't really know why we get this out, right? Maybe that you can go into deep down there, right? I mean, that's why if you look at my slides, updated slide, right, on the random forest, right? Actually, you can see, say for example, I update the slide for random forest. If you want, you can take a look. On that is if you try to run a random forest, that's what I do. Okay. is supposed to train the random forest. Okay, you tell them you want to feed 3 there, and you estimate it's feed 3s. You can also usually you make more than 3. You can maybe 100 or 500 trees. Okay, and then what you do is actually you will feed 3 different trees. And in this one, I can plot all 3 trees, and you can see the first tree take x2 first and x1, and the other one will take x1, right? And the other one will take x1. So the same data, you will feed 3 different trees, and the random forest will take the average output of these 3 trees. Okay, so there's some way to combine it, but that is beyond the scope of our class. But actually, they will feed 3 different trees and then try to combine, right? Because remember, random forest, right? What they do is to bootstrap the data, right? And each data, they will fit the tree. So the data actually used to fit this tree will be different, right? And the variable they use will be very different from each one. So you are fitting different tree, right? So basically, just to recall what's random forest, to be simple, it's just like you have the data, right? You bootstrap different universe, and each universe, you pick up some variable, not full set, but some set of random variable there, and fit the tree on each, and average outcome of that will be our prediction, okay? But of course, does it make sense? It's good for prediction, for sure. But what does it do, right? It's nothing with the original data, right? Using part of the data to do it, it can be all wrong, right? But in prediction, it can be good. But maybe it is a wrong universe, it's a wrong model, but it predicts better, right? So, well, is it what it is? Right, so basically that is what we have until now, right? So I guess that gives you the main idea that what you're going to see, right? I mean, maybe it's good. Before we continue, maybe let's see the, those of you probably in the, may ask me the past paper is already uploaded, right? Just to see that is, we do it 2 weeks from now, right? The exam is 1 hour. And then open book, you can bring whatever you want. It will be very similar page to this one. The main difference is instead of 10 multiple choice, I think I have 15 multiple choice question. And I have only 3 long questions, okay? So I cut out 1 long question and replace it by 5 more multiple choice, okay? And the length is very similar. And you can see multiple choice question is asking very standard question. And here I have asking some calculating question. But I think this year I'm not asking any calculating question, because last year I saw people spend too much time on multiple choice. So basically, this year multiple choice is either you know, you don't know, you don't have to calculate. So you know it, then yes, right? So it's more like the question style, like something like that, right? Say, suppose I ask, what R squared represent? This kind of style, if you read it, you know it, then you're done. Okay, you don't really need to calculate, so it will be more straightforward. But of course, we have 15 questions like that. And the long question will be the style as we have seen, right? It's just like, you don't have to worry Python code because the Python code is provided for you, and the output is already there, okay? So even though if you really don't fully get the Python code, it's fine, because I give you, you only need the Python output to answer the question. Of course, I also give you Python code in case you wonder what I'm doing, right? Sometimes you also want to look at Python code, what is generated, right? But mainly if you understand what's going on here, then you will be fine, okay? And then answer some question. As you can see, the multiple choice become easier. The long question part will be slightly more difficult, but otherwise it should be along the same level along this line, right? We have 1 question for regression. Logic this year is not the main focus, so probably you don't have to worry about logic, because as I said, logic may only appear in multiple choice if it appears. And for LISO, it's also important, so likely there's something similar to be here, but I guess last year is pretty straightforward, so probably it will be slightly more complicated version for the LISO. and regression tree and random forest is also important. So you also expect to see something like that as well. But last year is too easy, so it's slightly a little bit more complicated. But otherwise, it will be something similar. So if you do well in the, if you know how to do this, then probably you will get 80 to 90 points, right? At least 60 points for that. If you understand every single aspect of this, then you know what's going on. So far with now, right? Shouldn't be an issue there. And so you can bring calculator and bring any printed material. Okay, no computer, no laptop, no iPhone, no cell phone. But otherwise, should be all right. So as we are doing open book and everything is not very technical, right? So you expect that the exam is longer than on average person can finish. So don't expect you can finish it on average. I mean, if you get an A, then probably you can finish, but average, you are not, the median student in this class is not expected to finish everything. So you just try to do the question that you feel easy. If you're stuck, you just skip, okay? And then you don't really, right? You don't really need to, even if you can't finish, you can still get A. Don't worry about that, because I make longer than, I make more longer and more difficult than in general, because I need to distinguish who will get A and A minus, right? I mean, because the range in the past is too close to say. So I make it more difficult so that if you're very good, then I know it, okay? But otherwise, just don't be worried about that, all right? Because last year everyone is very good, so I have to make it slightly more difficult. But otherwise, and that should be the case. What else I should say? Oh, next class will be the presentation, right? So just to make sure that everything is correct here, okay? And then I will random draw the group. Okay, maybe I will open a Python and then draw a number there and then sampling out of that, and then the number will be there, and each one will speak for 2 minutes. And each one of you have to speak because I grade everyone. And the dressing code will be business casual. Whatever you think is fit for business will be fine, right? And I give grade for your presentation and your performance, and also you also would vote for the best group and best presenter, and those who are the best will get extra credit for that. Okay, so you can see who, you can vote for yourself, of course, but I'll collect who is the best, and then you get extra credit for those. Yeah, any question? I mean, that would be the thing, but if you are not willing to say it now, you can leave it in the, you reply later. Okay, what question or query or concern, that was the case. If no, then we are going to get to our chapter 9. So we go to now the regime of causal analysis, okay, and it's trying to establish what now is how X cause Y, okay? It really rely on much more than technical techniques, okay? We need to proceed, we need to make some assumption, okay? And so far, we don't have to rely on the real world, right? There's no domain knowledge required. We don't need to know what's going on there. Just a data, I just fit, right? We really don't need to know anything about what is X cause Y, right? And now we really need it. So that's the understanding of world will help us to understand what's going on. So that will be the causal analysis idea. So let us start, and then to be fair, this today's material actually is very advanced. So in order to work on a data to calculate X cause Y, it really requires a PhD to do it. And actually, a good PhD paper or good research in PhD level would be establish why X cause Y, right? Probably you know this year the Nobel Prize winner, one of them is the Dironesi-Moglu. Actually, who got Nobel Prize because he tells us one thing very simple we know is good institution would cause economic growth, right? Good government would actually need to nice growth. It's not about democracy or non-democracy. It's whether the institution uphold property right and all the other things as well. But that would be his discovery, right? And actually, 10 years ago, there's a economic historian, Dr. North, also get Nobel Prize for writing a lot of things. But he's the one who established causality in data. Okay? So, and a lot of people actually get Nobel Prize because he established X cause Y convincingly from the data, right? We know X cause Y, but is it X cause Y, right? It's not entirely clear, right? And actually, there are many people talk about in economics. I mean, there's many people making money. It's like, for living, it's like try to see if studying more actually make you earn more. That's a very important equation that has been studied until now. Is still people doing that, and it's not clear. So it's not entirely clear actually the nature versus nurture. Right? Is it where your IQ matters, or actually education make you better? But of course you're here. I don't know which one you believe, whether the master program make you more productive, or master program make you a title that help you to get a job. I don't know which one works, but I hope from this class you learn something important, right? You learn how to do Python, and then, I mean, I'm pretty sure that most of the material you learn from this class will be forgotten. But I guess when you look back, you learn the Python code, you know how to run regression, you know how to do machine learning, the basic idea that would be good, right? Because if you're really into this econometric analysis, you do machine learning in the second semester, that will reinforce your learning there, right? So, but I hope that that's what you learn, because I think if I don't teach class, I give back all my econometric technique to my teachers, right? But that's okay, right? You can pick it up easy later. So how do you establish causality? Okay. From a data, when you establish causality, you have to satisfy two requirements. If you don't have that, you don't have causality, right? Is you have to have, first thing is you have to have things that have intervention. Things don't have intervention. What do we mean by that? You say X cause Y. You must have, someone have X, someone have without X, right? Otherwise, you cannot compare, right? So that is the first item. The second item, it must be the case you observe the variation of the X, right? You have to be, say, compare those with X and those who don't have X, right? And they must be comparable, right? If they're not comparable, it must be before, after, right? People before don't have X, and after you have X. Okay, so that you have two requirements for that. Okay, so we want to establish outcome variable Y and treatment variable X. Okay, and do recall yourself, remind that Y in the machine learning or prediction world, Y is called target, right? X is called feature. But in this world, we call something different. We call treatment or causal or outcome, okay? And what we want to know for causality is to understand how or why X cause Y. Then we can pinpoint what's going on there. We will try to look at the cause and then look at the solution, right? That's what you do in medical exercise, right? You will do is, okay, you have two type of patients, right? You randomly assign they have medicine or not, right? And then you see compare two group where they recover, right? How fast they recover, and that's called the double-blind test, right? There's a lot of things going on there, and to see whether medicine is useful or not, right? And that is very important, right? Because you try to hold other things constant, and only changes the medicine, then you can tell, right? You can isolate the thing. That's very important, right? So that is the idea we try to do. Is in the experiment, it's easy to do. But in the real world, there's so many things changes in the background. So you have to be very careful. Cool? So that is the difficult part that we try to do it. Okay? So to understand this idea, usually that is causality, we will, if you look at the textbook, many textbooks there, then they will have a framework we call potential outcome framework. It's a theoretical construct to understand causality, okay? And that is the terminology that we use, and then you look at all the textbooks, it's like this. So we will have an individual I, okay, the subject I, have outcome Y. Y can be anything you try to measure. Maybe, say, IT manager, you want to see Y is, say, how much they interact with your system, or how much they spend on your platform, so on and so forth. It's something you care, okay? And there were two types of outcome, right? Outcome is treated, the outcome is not. This superscript 1 or 0, right? So you say you want, say, maybe the problem is whether X, the treatment, you want to study whether, say, your new design of the IT system or new design of your website, or some marketing effort there, right, will change their behavior, right? Whether they click your more website or they spend more money on platform, right? So it's something you want to study is 1, 0 is untreated, right? So you want to see whether actually why I1 is different from why I0, right? If they're the same, then probably you don't need that treatment, right? If different, then you think the treatment is useful or not, right? So this is something you want to do because why you want to care about that? Because you want to see whether you want to do things, right? For example, your IT manager, right? You want to implement a new version of your software, right? You claim that the software or new algorithm is going to improve efficiency or improve engagement or improve traffic, whatever you want, right? What you're going to do is to a beta testing on some subset of customers or tester and see how it works out, right? And compare and contrast, right? And that is the idea, okay? The main drawback, okay, of what we have is we only have one universe, okay? The problem is a guy is either treated or untreated at a certain period of time, right? So either this guy have a new version of software or not, right? But the thing is, if we are able to have two universes, one universe is he has the software, the other universe he doesn't, right? In that case, we can come up with two versions of him and look at the difference and we're done, right? That would be easy, okay? But the problem is in the real world, we don't have that luxury, okay? The problem is you only observe whether we give him or not, okay? You don't really know, there's only one chance, right? If you fail, then you fail. If you success, you success. You can't really say too much, right? It's very hard to tell whether you're successful or not, okay? So that means that, as we see here, right, is we care is the individual treatment effect, right? It's like a particular guy, right? We don't look at his treatment or no treatment, the difference of this, right? The problem is only observe one of them, right? We give him or we don't, right? Do note that you may say, okay, before he do the treatment, is YI0, after that is YI1, you may say that, right? But do note that time difference between the two, so they're not the same thing, not the same universe, okay? Unless you say the same before and after, okay, right? Right. If you don't have medicine, the status quo will be the same, right? But it's not the case, right? Because you know that human, right? Human before they take a drug, even if they don't take a drug, the white blood body or human mechanism would cure, right? If you don't take a medicine, it will cure by itself, or it will deteriorate, right? It can change the background. So it's a little bit more complicated, okay? And so that's why this cannot be found no matter what you do, unless you are parallel universe, okay? There's no way you can do it, okay? So you may ask yourself, often the time, right? What happens if you don't do this master program? What are you doing, right? I don't know. Maybe you become very rich, right? Or you can become extremely poor, who knows what, right? What happens if this thing doesn't happen? I don't know, right? You can't have another life, right? You don't really know what will happen if you don't have that chance, right? You can't really say whether it's good or not, right? Even if, say, if you graduate from this program, right, you become super successful, right? And then we don't want to claim the credit that is because of that. We might, but it may not be because maybe you do other program in Hong Kong U, right, or actually USD may also be very successful. Who knows what is the alternative, right? Or you do this, it's very miserable, right? After this program, you do the master program, and then you, go to do delivery, right? Or you go to do TikTok, right? Who knows, right? But maybe if you don't do this program or do other thing, you may still do the same, but you don't know, right? You don't know about it, okay? So you never know about that, okay? And the problem is also, the main problem is you can't rely on average because the problem is like every individual can be very different, right? So you can't say, why don't I just do medical treatment for one guy but not the other, right? And then let's compare the two guys, right? It's only valid if they're very similar, right? It's not valid if they're not. So that's a very important point we will make, okay? So the question is, we can't have this guy. So we have to some way to estimate, and that means that we have to make some assumption and have to be very careful in sample selection. So that is what we'll do. Indeed is what we do that. Instead of doing the treatment effect, which we never estimate, what we call average treatment effect. It's looking at, okay, we can't do that. Okay, why don't we do this average one by estimating the average of many people, right? So suppose that many people, some people treatment, people don't. Let's look at difference, okay? And this is the main thing we want to study. As I told you, actually there's so many people, actually this is what econ PhD do, many of them. In the US, actually, I think half, every year we're 1,000 PhD in econ, and at least I guess more than around 500 people graduate, and what they do basically every day like this, establish causality. It's very important in the scientific discovery, okay? Because I want to see a lot of time in the US or many places in the world, right? You want to do policy changes, right? Before they do it, they have to have pilot scheme and to see whether it's going to work or not, right? So in that case, you have to establish causality because everything is changing in the background, right? So you have to control things changes, right? Other things changes to establish whether this policy will work or not, right? And then they change it or not. In business also, right? Probably you know, right? A lot of places, especially platform, they hire economists to do this. Like Amazon, actually they hire several hundred economists to do this, right? Because they try to change the website and here and there. I think in China they also do that as well, okay? So they do a lot of things to establish how this caused that, okay? And do note that this can be zero because different people can have different treatment effect. Some people can be negative, some people can be positive, like medicine, right? Some people may be allergic to that drug, take the drug actually make them worse off, okay? So they can be zero, right? So that is something there. Now, the other one is, which often confused, and this is very important, is another concept is called the average treatment on the treated, okay? It's trying to look at the idea of the individual before they get treatment and after they get treatment, what difference, okay? And usually this is what we can measure, okay? Because you only have data of those people who grab, okay? And usually there's no problem if you grab people randomly, okay? If you look at people randomly, then you can have no problem on that. If people actually whether they get treated is not randomly assigned, then you have problem. So that means that your IT manager, okay, if you send new software to people, if you randomly send a software to people, okay, then you look at before and after, what you measure is correct, okay? The average treatment on treated will be same as the average treatment effect, there's no problem. But the problem is your new software usually tests by the people who's willing to test or willing to try out new things, right? Or they like your product more. In that case, you're only measuring that segment of the market. is not the idea that it can be generalized to general, right? Because maybe they like product more, they're willing to try new things, right? Then when you try to think this is going to apply in general, it may be wrong, right? For example, you are going to send your test software to people willing to in your experience program, and they're willing to try the new feature, are willing to learn. Their learning curve is not so steep, right? They're willing to try out new things. They're not stuck to the old system. Then it may work very well, but when you push out, right, maybe disaster happen, right? So that means that if you really want to see whether your system works, you should randomly send out the tests, right? It might or may not be possible. Okay? If that's not possible, how can we solve this problem? There's some way to solve it. How to convert this AT, ET, which is usually you do, to back to that one, right? Because you cannot randomly send out the software to your customer, right? It will become disaster, right? You can only send to some people that more willing to try, right? But how do we handle that problem? It will be something that we can talk later. Okay? So that means that we want that, okay? And to make sure that your data, if not random assignment, there will be something have to be worried, okay? And how to handle that, we'll talk about that later, but that will be two things, two ideas in your head, okay? So that is the first main bullet point we want to mention. The second bullet point, this is so important, is in causal analysis, is causal map, okay? This is the map that helps us to decide what to put including X in the regression, right? Because in the machine learning or LISO or whatever, you put whatever X there, the machine decides for you, right? And there's no human there, right? When you human there, it's like which form fit the better, right? Whether you include square term interaction, right? There's only the fitting, what fit the best, right? But now we have to tell you that even if it fit, sometimes it should be there, shouldn't be there. You should rely on our theory, rely on understanding of the subject matter. So that's very important, right? That's where the domain knowledge have to be there. And I think until now, machine cannot replace us that quickly on this subject matter, right? Machine can easily replace us for machine learning because they're doing better. But I think for this one, humans still better because we understand how thing works for us, right? We know what's going on. Machine cannot ask himself how he behave, but I think sooner or later, machine can replace us. But for the moment, we're still better in this one, okay? So what is this? It's a graph. We call this a direct acyclic graph. Basically, it's just a node with arrows, and there's no cycle. That's why acyclic. Direct means there's an arrow there, okay? So let's see the graph, and you'll see what's going on there, okay? An example will be like this, okay? So Y is our outcome variable, okay? This is something we want to, it's a target variable, it's our outcome variable, right? We want to have X is something we want to change, right? The new policy, new system, new design, right? And we want to see where X costs Y, right? If the good thing is, problem is Z, right? Some other factor, right? If you can hold other thing constant, which you would do in an experiment, you don't have a problem, right? Just change X, everything keep the same. Then always X costs Y. That's how you do in the laboratory, right? Just change X, let's see how Y changes. Hold other thing constant, right? But often the time, you can't do that, right? It's very hard, okay? Later you will see the main problem is the Z, okay? How this affect and X with the Z, right? And they are interrelated, so there's a problem there, okay? So the second term here is called mechanism, okay? And we might think X would cause Y, and sometimes MXY is what we can see, X is we can't see, right? For example, X is, suppose Y is how much money you will make, okay? X is how smart you are, okay? But how smart you are, you can't really see. You measure by IQ, right? Or education, right? So you want to, this is something we can see. We change this through your IQ, right? And that, but or MX is your skills, right? The more smart you are more productive. You write better code, you write more efficient code, right? You are likely to deal with people better, right? Then that is the way the mechanism means. Okay? So that would be the idea, or what we call mechanism. Okay? And of course, the reason what we want to see is how X changes affect how Y changes, right? So that is the main idea, right? The causal analysis is try to see how X cause Y, right? If X never changes, you cannot say anything, but X change cause to Y change, but how X cause Y changes. And okay, the problem is first is it's called the random assignment, right? Is if we have some subject that has X changes, right? Some value, for other subject X has another value, right? If those with treatment and no treatment are randomly assigned, right? And that means that for this equation, right? Those who got a treatment, who have no treatment, right? And the value you observe on average, okay, will be this number, right? So if you random assign, okay, then the conditional probability that same as the unconditional one, right? It means that because you randomly put them there, right? And they randomly got the treatment, so then what you observe will be fine. So that is the easiest to understand. Then we're done, right? Just take a difference, then we're done, okay? But the problem is, in general, it's not the case, right? So why X changes can be due to many reasons, okay? And there are two types of variation. One is called exogenous, okay? And that is only affecting X only, okay? And the main problem is endogenous variation that would affect both X and Y, okay? So, and the problem is I only want the causal effect X on Y, so I only want the variation in X, okay? So to be more clear, what do you mean by exogenous and endogenous? This very important point is like this, okay? So there's X cause Y, we want to study how X cause Y, right? And the exogenous is like Z1, right? So the only thing that contributes to Z, right? And go to X and then go to Y, right? But there's a Z2, right? So that also affecting the both. So that is called endogenous, okay? So we have to distinguish that. And later you will see if you want to establish X cos Y, okay? It will be useful, okay? To help us to check, okay? And Y and the Z2 will be problematic thing. We have to be very careful of the control, okay? We'll be telling you that if you do prediction, you would include Z1 and Z2 if they help you predict, okay? But if you want to establish causality, you have to be careful. Sometimes you have to include Z1, sometimes you don't, and same as Z2, okay? So have to distinguish different scenario, then you will notice when and how and why what to include in regression. We'll talk about that after break, okay? So that will be after break. We'll talk about different type of variation and when you would put what, okay? But let us take a break of 15 minutes. You can do the U reply and tell me what you know, what you don't know, and what you don't know more, because I guess this is the second last U reply you're doing, okay? And the next break we'll do the very last U reply. So Let's resume at 10:35. Let's see, second to last, you reply, see how well you're doing. Oh yeah, we did talk about the test. Test is 1 hour test, right? It will be two weeks from now. Be here, open book, open notes, no electronic device, bring whatever you like. That's it. I mean, there, okay, it's good to check out the past paper, right? I think at least there would be the correlation coefficient between past paper and current paper would be 0.8. So that's why I said on average you will get 80 points if you understand what's going on in the past paper, right? Because past paper is designed to test the main thing, right? So every year should be same but similar, right? Asking the main point, but of course in different angle, in different direction to TC whether right or wrong, right? So it will not be exactly the same, but the concept that being asked will be the same, right? You apply in different contexts, right? No matter what exam is, right? Or what are the courses the same, right? Because the main content is there, but different way we want to ask to see how you apply the concept, right? So I think the easiest, right? The best predictor, right? The best thing to do, right? You learn from this class, right? The best thing to do, right? The unbiased estimate, look at the past paper, right? That's the best thing to study. Presentation, as I said, right? Everyone will get 2 minutes sharp. So I will bring the timer there. Beep, 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 you just stop, okay? Everyone get 2 minutes. And then you have to vote for your friends, who is the best guy and best presenter, right? So I guess that's the case. If you have any question, you can ask me in the second feedback. I don't know whether if you really miss it, I'll upload the lecture, then you can check it back, right? So if you worry you miss anything, just check the video there, right? If I forget to mention. Exam is 1 hour. I think we will start like, I think our class is 9:30, right? So I think we will be something like 9:45, something like that. Okay, we wait 15 minutes before. But you can come in at 9:30, then probably will be 9:45 to 10:45, something like that. Okay, I mean, depends on when you can sit down, right? But the expected time to start is like 9:45, something like that. Okay, but please come at 9:30, right? Because if everyone is there, then probably we don't want to waste too much time, right? So, but that will be expected. Okay, 1 hour exam. How to choose good treatment variable? No, treatment variable is you decide what to treat. You want to say that what X costs Y. It's a choice. You want to say new software version to implement is your decision. The treatment variable is your decision. You want to see whether new software improve your performance. What you want to measure is Y, right? So it's your desire. You want to study whether this thing has some impact, right? It's your choice. Calculation, but of course you decide what it is, right? You want to study what cause, whether X changes cause Y changes, right? In the prediction model, we don't really worry about whether it actually X cause Y because it can be they change together at the same time, right? Or there's something had happened, third thing affecting both. You don't care prediction because you just want to predict. You say X to predict Y, right? It doesn't say well actually change it X cause Y, right? But now we want to establish whether X cause Y. This is important in business decision because you want to change X. It's your choice. Okay, so that is it. Okay, and the main problem is you only have data of X and Y, but how to establish this? This is what we want to study, right? Of course, if you, as I said, you randomly assign who to get X, then your problem solved, right? Because you're doing experiment, but in the real world, you can't do it. So how can we solve this problem of non-random assignment? Or there's some other thing changes, there's a problem, right? For example, the problem is, say, suppose you have new software and old software. The new software, right, is implemented today, right? The old software performance is yesterday or last year. So the time between today and yesterday or last year is different. Okay, how can you control those? That's an important issue there. We talk about many different techniques, okay, say difference, regression, discontinuity, all these things will have to be there. Okay, so there is some issue there. Okay, but we will talk about that. So the book may not cover, or what do you mean? You mean the textbook I mentioned? Well, the textbook actually cover more than we do. We just cover a very small part of the text, 80%, 60% or 70% of the textbook, right? So I think they cover, right? Or except the book doesn't have Python code, right? Directly, but you look at the website, right? The website, the GitHub website, they have all the Python code, okay? But my version of Python is much simpler than the code that provided by publisher. And the Python code they have is much older. I think the code they published is like 3 or 4 years ago. But you know Python is a new language, keep updating. So the code you can see there is very outdated, okay? But my code is more updated than the one they have. So if you try to run their code, they will complain. If you try to see, there are a lot of wrong thing there. So I update the code already. What should we show on presentation? 2 minutes, what you can do, look at TikTok short video. You present the most important thing. That's the business presentation. You try to present the most important thing and forget what's not important. Okay? So you have to present the most important thing, right? The most catchy thing there, and then just tell you the thing, and then that's it, right? And then if I want to know the detail, I read your report. Presentation is just advertising tools to make me feel your project is important. I want to read more. Same as your report, right? I mean, you want to present the main thing in the one-page report, right? And then you want to put the detail in appendix if you want, but otherwise, you tell me the thing. If I think it's reasonable, I trust you, and that's it. Right? Grading standard, I think that's business standard, right? Professional, I expect you imagine I'm a client, or I'm the manager, I'm the boss, or I work for you, or I try to understand what's going on there, right? Yeah, it's 1 hour exam is same as this one. As I said, I want to make 2.5 hours, but I think you guys are too busy anyway. So if I make 2.5 hours, then it will be very tough. So I make 1 hour. Then I make a shorter exam. That means that I can make an easy exam. All right. So that is a challenge there. With our test, no, because the test is up to the material covered last class. Okay. And this class's materials, I think, is too advanced to be put in your exam. I mean, I actually easily do it, but that I think I know you're very busy with all the exams and things, so maybe cut off is last class. You cut off. This class actually is very important, as I told you, right? Because you want to make business decision, you want to understand causality. But as I said, if you want to really know causality, you would have to study a PhD, or you have to at least have a 1 semester course to do it. If you look at Econ PhD, right, they would do actually 3 to 4 class, 4 semesters to understand how to do causality there. Okay? But if you have a question, please feel free to ask. Yeah, if you want, it's Friday, that's good. The weather today, oh, it's rainy, yes, that's great. The speed, is it okay? So far, okay, the mean is 3.9, so it's good. It's 3.8, so it's a good number. Oh yeah, I think rain is a bit annoying. There's a problem, yeah, right. I guess it's, you like it or hate it, depends on whether it's convenient or not, but true. Seriously, I think raining is not suitable for sleeping. Right? I think when hot, you want to sleep. When cold, you want to work. But I don't know, maybe it's just me. But again, suggestion, coffee, if you feel tired. So I hope I answered the question that you might have, but let's continue on this one, because by looking at this graph, later I'll tell you, or actually you should know from this class is what should be put in the regression, or you put in the machine learning for machine to learn, okay? And what shouldn't be there, okay? So we call that what is exogenous endogenous in the graph is if only thing that point to x only, that is exogenous. If point both to x and y is endogenous. Okay, that's two distinctions. And exogenous is good and endogenous is bad. Okay, so but let's see. So what are the exogenous variation? There are three types. Okay, and we have the three ways to do it. Okay, first one, if it's control experiment, like we said, is you decide, right? Because you decide who get treatment or not, right? And in the case, it's easy. Okay, that is easy then, because if you do random assignment, then you're done, right? So just run the regression, then over. Okay. The next is like natural experiment. Okay, it's like earthquake, some policy changes. Okay, then you can see that part. Later you will see we do different difference DID. And that part is also how we can use the technique to handle it, okay? And that part will be also help us. The last thing is conditioning, and very often this is the part that panel data will kick in, because you want to see maybe whether you get treatment is because of things that affect you, right? Say suppose you want to study X, okay? And Y would be X is whether you study a master program. You get an ITM degree, okay? Y is your income. You want to study with ITM income. ITM degree help you to make your income higher, okay? So if I have a lot of money, okay, I randomly pick people on the street and tell them you get to come into the master program, right? And I look at the difference between the two, then I can know the value of this master program, right? If I do that, I'm done, right? I randomly pick people on the street, you get the master program and you don't. If I can do this experiment, I'm done, right? Or it's a natural experiment, right? Where say there is a some government or natural phenomenon make everyone go to study master and some of you don't, right? Or the natural experiment that maybe some people enrolled in the master program, but suddenly for some weird reason they don't come, okay? Or their visa got denied that they don't get a master program, right? And you can compare and contrast, okay? And conditioning is looking at, hey, whether you get the master program is because whether you have money or whether you receive advertising, right? If you can control that, is also like this case, but that would be the idea behind, okay? So let's see the first thing, right? If it is you who design this, okay, variation, okay, that's a good one, okay? Then you just run experiment, right? You run the regression based on your control, then you're done. You don't worry about this guy. That is easy. Okay? And the main problem is the confounder Z, right, which is affecting the idea, right? So what we call the first one is the common confounder, Z affect X and Y, right? So in particular cases, X is a treatment whether you study the master program ITM. Y is the income, right? How much you earn after you get a degree, right? And there's a common confounder is your IQ, right? How smart you are, right? Usually we think if you are more smart, you're more likely or more hardworking, you are more likely to do the master program, right? Because to the master program, you have, the ITM, the very famous Java program, right? Or the other complicated, very hard course you have to spend a lot of effort to pass, right? And you have to spend the time here, right? 1 year, right? And also, if you are smart, you're hardworking, you're likely to make more money anyway, right? So how smart you are or how hardworking you are affect both the decision whether you take the master degree and also how well you are actually performing when you go to the job market, right? So that's a common confounder. And also there's reverse causality here, right? It's because if you are smart, maybe you have high income, then probably you already want to do master program, right? Because master program is expensive, right? If you are not have high income, right, you are not going to spend on the master because you think you have good income, right? Then probably you want it there. There's a feedback loop there, okay? And the next is unwanted mechanism, right? It's like if you get a master, then probably maybe improve your skill, right? That actually let you have higher income, right? That's what we want. But there's one mechanism, right? Like here, if you come to this master program, right? You may meet the prince and princess, right? You get married, you enough, then you get a good income, right? Then this unwanted mechanism, right? It's not the reason that we want to study, right? It's not you come here, you get a relationship, right? Then you get a good job, then it's not something we want. Okay? So that is a different part. Okay? As I said, confound like this one, right? Say the Z, okay? That is an important problem here. Okay? And as we said, right? Confounder here affecting both, right? How hardworking you are, how attitude, right? Affecting the both, right? How smart you are, right? Or how good your parents, right? If you have rich parents, then they support your master program, but also may also help you get a good job, right? So that is a complicated part, right? And this unwanted mechanism, right? Master program affect your income, right? Through the skill, of course, what we want, right? But it can be the case you meet how I meet your mom, right? How I meet your dad, right? The problem, right? There's a problem, right? You don't want that happen. Okay. So usually you want to control the confounder, right? Because that would be the part that affecting the thing. But the problem is whether you have that data, right? If you don't control that in your regression, you don't control that you have a problem there, right? The confounder is the thing that you should put in your regression. If you miss them, there's a lot of issue, right? Suppose I want to study, go back to this question, right? I want to study whether master program affecting your income. If I don't control your family background, right, the regression will be wrong, right? Say, suppose I have data whether you have very rich parents or not. If not, it's omitted from data, right? You can't really estimate how X costs Y. So when you run run the prediction, you don't have that. You don't need to have that. But when you run causality, you make sure that you include all the confounder, especially this type, common cause confounder, you include them. If you don't control it in your regression, your estimation is wrong, right? In this case also, right, you have to control whether this guy studied master program and got very high income. It must not be the case that he actually met the princess or prince there, right? If they met there, then things break down, right? And reverse causality have to do some other way. I mean, we will later learn this require a instrumental variable IV to solve this kind of problem, okay? But that is not, this one you have to control, and this one have to be, use some other advanced technique to do it, but 1A and C is easy to solve. And of course, you learn from regression, if you omit something you should be there, then you make a lot of wrong mistake there, okay? So, before we said what should be in X, okay? You should try to include X. And here is the 3 example that you shouldn't be X there, okay? The first is called exhaustion variation in X. The second is mechanism, decide what is common consequence, okay? For example, okay, if you want to study the X cos Y, you shouldn't include the thing that lead to cause change in X, okay? The reason is because you want to study how this impact this one. If you run the regression X with this guy, then this coefficient will be significant, right? Then you underestimate the impact, right? Because you know this caused this anyway, right? So you shouldn't include the source, right? For example, maybe there are some genes factor that affect whether you want to study master program, right? There's only affect there. You include that information, that thing fails, right? Actually, that's a good thing. It's a good idea because you don't have to include everything that affect, right? For prediction, you may want to include that, right? You want to predict, that help with prediction. But this is not good for discovering causality. Okay? Later we'll put in practice, you will see what should be included, what should not, but that should be avoided. Okay? And the mechanism are the same. Okay? If X cause this and here, right, you shouldn't be that, right? Because remember X is the master program, say, right? Y is the income. Conditional would be how well you do your Python code or how well you do your Java coding, right? And you shouldn't include that, right? If you include that, that'd be wrong because I want to see how this affect, right? Not including the how well you script your Java, how you script Python, because that would you would have coefficient here, right? That will not get it wrong, get the right thing. Okay, so it should be if you include them, that's wrong. Okay. All right. The next thing is here is X cos Y, and both X and Y cos something, right? And this would be, if you include that, then because this would go together, right? Run the regression, this will be consistent, but this is not the cause. You include the regression, that would be wrong. All right, so that would be the idea. So that's why you can see this. If you see this, shouldn't include your regression. Okay, so this shouldn't be included. Okay, so we'll put this in practice so you see what should be there and what shouldn't be there. We'll later put this into a practice and you understand or draw the graph, then you will see what should in the regression. Okay, but after all the graph, okay, the graph only tell you that much, right? And you have to think about one more thing is we only derive causality from the data we have, right? Have to think about whether this data is representative, right? Remember the first class, garbage in, garbage out, right? So you have to make sure that first internal validity, whether what we do is actually good enough, right? Is the variation of X, right? Is it something coming from which source, right? And whether they can generalize, right? Because the variation only comes from data, right? As I said, right, if you want to check your software, you send it to your user, right? If you just check it to say in the US market, does it generalize to the other market in the world, right? Or you test your software in Beijing area, is it going to apply to Shenzhen, Shanghai, so on and so forth, right? Because that would be the idea there. So let's look at the example, okay? And you will see the map there, then you can tell me whether what should be in X, what shouldn't be, okay? I'm not going to detail in here, but I just want you to draw your attention on the data, okay, quickly. So this is data from the US looking at how people eat and health. Is MECHA, right? Probably you know it's Make America Healthy Again. If you look at this recent news, right? It's like people want to see if more healthier diets help avoid high blood pressure, right? This is a very important thing, right? You want to establish causality, right? Turn out to be very complicated, this problem. And actually this is a multi-million question. So still now people still studying that, okay? And this is the graph that we want to look at, okay? The first is how you come up with this graph. It requires your scientific knowledge or past history. That is very important, right? We have to establish that, right? For example, how wealthy and what is social status affect whether you eat fruit and veggie, at least in the US, right? Because very often meat is cheap compared to veggie, right? So only if you are rich, you can eat veggie and fruit, right? And also if you are wealthy, then you care about your health, right? And if you care about health, then also you would have more healthy lifestyle, less healthy food, so less unhealthy food, and better lifestyle then will actually lead to better health condition, right? And whether the taste, right, whether you like it, affect also whether you like the food, right? And the problem is like this, right? If you high blood pressure, the doctor will tell you eat more veggie, right? So that's a reverse causality. Okay? Then probably you would see what should be included, what should not be included, right? So first you can see the taste. Should be included? Yes or no? Who think yes? Who think no? No response, okay? So taste is what? Go back to this. This is X. This is Y, this is Z, right? Go back to the. This is this one, right? So shouldn't be in your regression. It can be your prediction if you want to predict only, but this shouldn't be in your causality there, right? Because it's a bad condition. Clear? So it means that okay? What about this one? Should it be there or not? Okay? Make it easier. Okay? You have to think about whether this should be here, or this thing is whether to be here. Okay? That I will leave you for thinking. Okay? Whether they should or they shouldn't be there. Right? I think one thing is, should we include this guy? Should this guy? Easier. Should we include this guy? Yes? Why? Yes or no? I mean, of course, what's the reason? Let's check. We probably don't want to answer, but let's go back. This affecting this, right? But the problem is you go this one, right? So it's affecting this one and affecting this one. So affecting both, right? So it will look like this one. This is the confounder, right? So as I said, confounder you will have to control them, right? Otherwise, you have omega bias, so yes. Right? So that's the idea. And, right? So this is also common cost confounder, right? Because it also go in this way, right? You also go in this way, go in this way. So you include this, not include this, right? And this is the mechanism, right? So mechanism should not. Maybe I should use other color, right? So it looks like the graph is too crazy. Let me draw it again. I use red to say no, right? That, right? And then we use the, I don't know what color is good. Blue, right? And this is only affecting this one, right? What should you do? Should you control it or not? Yes or no? Think, check, just like. Go back, check, let's check. What about what is only affecting Z? What are you going to do? What are you going to do? Do you do anything? Do you want to control that? Do you or not? You think only changes Z, only Z only changes Y. Do you have to control it? You do control it. Right? Because that's the source of not weighted X. You don't control it, then you omit variable bias. Right? Of course, if you don't include that, doesn't really matter anyway. But it doesn't really matter. But you should include it. I mean, help you a better regression. Right? And this one, reverse causality is complicated. You need IV. Okay? You need instrumental variable. That is we cover in the technical slide, but so you can see what should be done there. Right? Look at the graph, you know how to do. Okay? But at least I think this is complicated, right? But at least you know this is close, why that 2 tick is above there. Right? Is that clear? Or we'll go with another example of the break, and you see what include, what not include, right? So here just correlation, but just to make sure you understand what the data is very fun. Look at C. If you're more veggie, it goes down, right? So it's at least pay to eat some veggie, right? But you don't have causality here, don't worry, right? Because we don't know, right? Because as we said, there's a reverse causality, right? Maybe you're high blood pressure, then they don't care anymore, right? But anyway. So here you see you have more money, you have more veggie, right? And your more healthy style people have more veggie, right? So that is that's why it's so complicated. And then in US, right, people eat potato chips, right? And because the stomach is always a fixed amount you can stuff, then you can see the people who eat more potato chips actually eat less vegetable, right? So that's from the data. And the data, the regression, yeah, they don't have regression at the moment, but that is this negative positive actually drive in that table. You can see positive negative here. Okay, but that is the thinking in your head. What's going on? Then you run the regression. Okay, is that okay? Now, is this okay? Then the next one I will try to talk is after the break. Okay, we'll give you another example, a little bit more detail on what we actually do when we have observational data, right? If you have control experiment, it's very simple, right? You just look at people who got a treatment, people who don't have treatment, take a difference, and you're done, right? And very often what you left is the data, observational data, right? And in that case, you have to think how to include them or how to not, right? Just like this slide we have here, okay? Is what you should condition and what shouldn't, right? And you have to control, right, if there are an endogenous variation. For exogenous, you don't control it, okay? Just remember the graph. 3 say 3 yes, 3 no, right? And the way to handle is require you, the first one, which we focus on, is from the regression, right? That's what we're done doing. But of course, you need not worry about regression. It also applies to LISO, applies to machine learning, right? Although it's a regression, but you can learn, you can do whatever we have just already done. And one thing that probably you have to understand is when we do causal analysis, okay, we usually don't drop variables or we change variables based on whether it improves the RMSE or R square. We just include everything we think is reasonable. Okay, that is usually how we do. Okay, that is something different from the machine learning world. Okay, so these two will be a little bit more complicated, but I'll outline what it is. The main thing is you can do for the moment is this one. Okay. So always when we try to think about when you do causality, that is very important to do thought experiment. Okay. You can imagine that suppose we can do whatever we want. You have what data we want. How can you show X cause Y? What should be done there? And look at the world, what the data you have, what the limitation for data, your method, then you can compare and contrast and what's external validity and internal validity you have. So always you start with this thought experiment, what you can do, okay? What actually you can do, right? And that's very important, okay? They look at the textbook of causality. The first chapter, usually they tell you this. I mean, this is the thought experiment. What can be done? If you have infinite money, you don't have law, you can do whatever you want, then what should be done there? And compare to what you have. Okay, then you see the limitation of your study. And the second thing is, after that, you draw a causal map, and then you can try to continue. Okay, so that would be the case. Okay. Okay, I guess let me stop with this causal map here. So let me give you a few minutes more. So here is the experiment we want to say is, okay, a corporate finance study is whether you want to see is company that owned by the owner, the founder, and also or the family, is it going to manage better or worse, right? Two potential story is family. They think the company is theirs, so they would, of course, they own the company. Of course, they want to work better, right? Because it's their own company, right? They don't want to harm it, right? But on the other hand, it can be worse. Is because they may not be the expert, right? And second is because they're the family, right? Because they don't care that much, right? They want to enjoy their life. They may be worse manager, right? They want to slacking, okay? Because they have money a lot. They have a lot of money, right? They don't really want to spend too much time on manage the company. So that's a problem here. It's not very clear, right? So let me skip all the crazy thing there. We go back here, but at the end, this is the graph, okay? mean, you can look at the theory behind, but what we want to see is whether the founder or family owned the company actually lead to better management or not. Okay? And you can see there are many potential arrows there affecting this X and Y. And I'm not going to go to slide to explain why, because we are not a corporate finance class, right? But let's assume this is a graph, right, that I try to explain, right? If you have a good family, right, then you have a family, then you can have family owned. Otherwise, if you're on your own, you don't have family, you don't have that, right? And the bigger, the better the family, then of course you are likely to have that, right? And if you are in the industry, it's very complex, right? Then you need a lot of manager with different skill set. Then it's not likely to be family owned, right? Because unless your family is super smart, right? Otherwise, it's very difficult, right? But also, it's also affecting the management quality, right? Because if you have a complex technology, it's not easy to manage, right? So, but it's unclear which side you go. Also, the culture, institution, affecting whether family owned and management quality, right? Because the culture, like the family should help each other, right? And they should be loyal to your family, so hardworking. This one affecting the both, right? And also competition, right? If competition is very intense, it's unlikely that this will be good, right? But also affecting management quality, okay? And if the management quality is good, likely the firm will stay there, they will live longer, right? The firm is bigger, right? And that the firm is bigger, live longer, less likely that their family owned it, right? So there is this graph probably come from our knowledge. So the question for you, if you got nothing to do during the break, is to think about which should include in your regression, which is not. Okay? If you understand what's going on there, actually there's answer in the slide already, but try to not look at it and think about which should be and which shouldn't. Okay? And that will be something it's good to do during the break. If you have nothing to do, we'll talk about that after the break. Okay? So let us have our very last final you reply. You can do it and then tell me if you have a question, just let me know. The break of 15 minutes, then we will resume at 11:35. 你有2分钟，你可以做 slide，也可以不做 slide，也可以，都可以，你自己决定。每一个人2分钟。如果你只有你的话，如果你只有你组只有你一个人就是如果4个人有2个人就10分钟。 So before we go to our last section of teaching, let's see if any remaining question remain unanswered. What is different between confounder and instrumental variable? Confounder is the thing that, say, Z is affecting both X and Y, right, simultaneously, right? This is confounder. Remember, we have here, go back to the confounder. There's a three type of confounder there, right? So either you have this affect X and Y, and this together, they're related X and Y together. That's a confounder. And one of the problem is like, in particular cases, this reverse causality, right? And how do you handle this kind of problem? And how can you avoid this thing happen, right? Is to think of the following. There should be, you cannot really use X here, okay? You think another variable called IV, okay? That actually affect this guy, but not here, okay? That is how we study, okay? That is standard demand and supply analysis, right? And how you, if you study economics, right? That's the easier thing is like, you have price, quantity, right? You have the demand and supply, right? So how can you solve this problem? Because demand supply are interrelated, right? So in order to figure this out in econometrics is you try to figure out what affect demand but not supply, right? In that case, the demand curve shift, right? Suppose people have higher income, then new demand there, then you can look at, they can trace out this one, right? Same as you think about things that affect supply, not the demand, then you solve the other one. Then you can trace out this demand supply curve. That's how actually you do it in practice. That's the IV thing, okay? Is to solve this particular confounder, okay? But that is, I mean, usually it's beyond the scope of a class, but that is how we would do in this way, okay? So I hope I answered the question, at least some idea, okay? Yeah, so there's a three type of confounder, a feedback condition. So feedback conditioner, you shouldn't be there. And the three type confounder, you somehow control it. Reverse causality is very difficult. So we have to figure out some smart way to do it. As I said, IV is the one way. The other is called regression discontinuity, RD is the other way. And there are many other ways as well, but the main way is IV. Okay. So since no questions, so let's go back to here. So now here comes to the question, as I posed before the break, is which one should be in your regression, which one shouldn't? Okay? So first again, do you need this guy? Do you need this guy? Okay? Do you need this guy? Anyone who's saying yes? Have a no? Yeah, no, right? Because this is something, if you go back to the very beginning, not too far that way, this is this guy, right? So you don't really need to worry about that part, right? Because worry about that part is exogenous variation, right? So that means no control. Okay? So that means yeah. Okay? So what about this common cause here? Who think yes? Who think no? So this is common cause, right? Common cause confounder here, right? And is to control, right? You remember that. This is the graph like here, this one. If you recall, we go back to here. It's the A affecting X and Y. At the same time, you control them, right? So that means we need to, I'm not moving up and down, so I just do this, okay? This is take, this is take, right? And what about this guy? Manager. Manager is no, because it's a mechanism, right? So just did that, okay? And competition is also the same, it's the common cause confounder, so take. Okay. And this is reverse causality, right? Then you need some IV to do it, okay? But usually if this is not too much problematic, if you think this part is not a big deal, you don't have to worry, right? So you may control it, or you can just pick up those companies that were similar size, right? Then solve the problem, right? If you pick company that is similar age, similar size, then probably you don't have to worry too much about those, right? And if you pick different size, then you have to be worried a little bit about that, but otherwise, you want the regression, include this and this and this, and then it should be fine. Okay? So that's what the book said. I mean, of course, to properly handle this guy will require you to understand what's going on, have to more technique there, but otherwise, you know, basically, if you come up with this graph, then we know what to put in X. Right? What to put in. You want to look at the coefficient, but you have to control this in your regression. Okay? So that's what we meant by go back to, sorry, just jump a little bit. That's what we want to do, the tools one, okay? We want to run the regression, right? Y is the management quality. X is whether family owned, right? You have to control C1, C2, C3, right? C1 may be competition, maybe technology, maybe culture, right? But do note that you should then include family characteristic, right? Some there. You shouldn't be manager there. Okay? So that is, you run the confounder, then it's a good estimate ATE. That's it. That's what I want to say for this chapter. Okay? Of course, there are many other tools like propensity score matching, IV or thing, but I guess I don't have time to go over them because also, if I just mention, you should know the name, very good. Just know the name, you can check out. If you have time, you can take a textbook. They call matching. The term is very simple. It's not running regression. You just focus on cases that are so similar, right? So suppose look at the firms that have the same technology, they in the same competition, right? Then just look at the difference, right? So that is how you do it. And sometimes you can do a cost matching. Another way to do propensity score. I don't want to go into detail because the time constrains us to go into very detail. And there's other way to do IV and ROD, but that is to solve the problem of causality. But I'm not going to go into detail on that one because we don't have time for that. And to actually study that actually require at least half a semester to master that part. So I just leave it for you because I think ChatGPT can help you to understand what's going on if you really want to do it. But I don't think we need that for our class, so that's okay. Just skip it. And as I said, if you really want to study, there are many material to understand, but the time we have is very limited. So what the remaining time is, I want to focus you on the two technique, or especially particular one technique, is called DID. That is the most important, and then I guess you can do it by regression as most often. And I would say too many papers that focus on DID. I think that is more than half, at least more than half, or to 80% of the study on causal analysis based on DID. Okay. And panel data very often is panel data and DID. So you would do combine them together. Okay. So that's why these two techniques is usually do it together. Okay. And panel data means that you have observed the same individual over time, right? And they get the treatment in different point of time. So you can look at what they do before the treatment, what they do after the treatment. So why is important? Because panel data is like you observe the same guy over time, right? That means that you can control his individual characteristic, right? So, but that would be the main thing. But I want to look at the DID because that is very often that you would have when you're IT manager, right? You look at the same guy before you give him the new software and the old software, right? Or a new design of your system, before and after. And panel is not everyone had the same treatment, right? So you have to do it a little bit more complicated one. But let's see how we can do it, okay? So the idea is the following. So DID is a special case for the most similar case is you have panel data where the data is divided into two groups. Some people have the treatment, some people do not, right? So it's like some people receive new software, some people who don't. Who have new software is treated, who don't have is not treated, okay? And you also have the two period of time is whether you have their activity, their measurement, before they have the old software, old version, and they also have the new version, okay? And the guy who is not treated, they have always using this old version software. Is that clear? So two group of people. Untreated is those who have been using old software all the time, okay? And the treated version is they use old software before and use the new software after that, okay? And you may ask the reason why we need this, right? So then we just look at the people who have old software and look at new software, look at difference, we're done, right? Why we have to do that, right? Because if you do that, it's the treatment on the treat, right? Every treatment on the treated, right? Look at before and after, right? We give him, that's fine, we're done, right? If we randomly assign who get treated or not get treated, it's fine, right? If you randomly assign that, you just compare before after, you're done. But the problem is you don't have that luxury of randomly assigned people, right? So the best thing is you have to figure out the control group, the untreated group, okay? Because the untreated group will capture the background effect, right? The background effect is because treatment, right? Whether you give software or not, is the time difference, right? You may give you have data that use old software last year. The new software is in this year, right? Unless you say this year and last year are exactly the same, fine. If not, then it's not comparable. So you have to compare the baseline, compare the benchmark. That is what we call diff and diff, okay? Because difference between the control group and treatment group is not the comparison. You have to compare the control group before and after, treatment group before and after. There are two difference, and difference between the two difference is difference. So to put it in math, it's like this. If you have the control group, the difference capture the background effect, right? Because they keep using the old software, right? If of course the background is unchanged, they should be the same. But the background changing, right? Because maybe this year economy is different from last year economy, right? Or this year the market is different from last year market, right? Or they use the software, they learn how to use it better, right? They change, right? So that's a background effect. And the difference between the treatment group have two things, right? It's the software effect, the new software, and also the change in the background. So that's the difference. So the difference between the two will give you the result, but that's why you call difference. Right? So that's the idea, right? So basically it's just like this. You have before and after, right? So you have the treatment group and control group, okay? And this difference is captured here, right? Treatment effect plus background effect. And the difference is the background effect. You take the difference of these two and give you the treatment effect. Is that clear? So that's why you call difference in difference. Okay? So that is the, I think the single most important tools there to understand the causal inference, right? Right. I think this is how you do experiment, right? You look at the plants or chemical, right? One is you add something there, you don't, right? Look at, say, you look at difference before and after, and the treatment before and after, look at difference. So that is the model. And that's how we run the regression, right? You look at difference, the variable there, you regress on the dummy variable they got treated or not. The coefficient there, the beta, is exactly what we want, right? So that's done. And of course, you have to add the confounder there, right? And we told you already before the break what should be in the confounder, what should not, right? The good should be there, bad should be gone, right? And you have reverse causality, you need IV. But otherwise, that would be the case. Is that okay? Of course, to be expert on that, that will be something complicated, but I hope that is the main idea. The main graph is like this, okay? I hope this will make sense, right? So you have two groups of people, blue and green, right? If you don't do anything, right? You're expecting that it will go in this way. That's alpha, right? That's what the background effect, right? If there's no treatment, you're expecting this is going to the same direction, right? But because of the treatment, you would go up by this, right? So suppose this is the case, right? This is your friend who do not do ITM master, and this is you, right? And both of you, if you don't come to CHK, your salary next year will go up, right? As normal. But now you do the ITM master, right? Your salary jump like this, right? By looking at the difference minus the difference of your friend, that will be the impact of the master program, right? So you have to compare that, because otherwise, because you get older, usually you will get higher wages anyway, right? You are more experienced, okay? So that's why you take away from that, right? Because when you look at the case where counterfactual, right? Because this is what we call counterfactual, right? Because I don't know what is your salary if you don't do the master program, right? You work in the industry for 1 more year, right? Then we look at, okay, suppose you don't do the master program, you should behave as if your friend who don't do the master program, so your salary go up in this way, right? By looking at difference, then you can see. Is that clear? So this is a very interesting study. I think this is also important for business, is merger analysis. Is asking, okay, if two firms merge together, right, is it going to benefit to customer, right? Is the price goes up or goes down? It's unknown. Usually there are two forces is working there, right? If firms merge, the market has fewer firms, the price tend to go up because less competitive. But on the other hand, if firms merge, they're getting more efficient, right? Because they can fire many managers, overlapping, right? They're more allocate more planes easily, express airplane, right? So you can save a lot of costs. So there are two ways to go. So actually, when the government, same in China and the US, they try to look at when firm merge, they want to allow it is only want to allow when the price doesn't go up, right? Because otherwise, if they merge, the price goes up, it's not good, right? So here's look at the case, and this case is allowed it. American Airlines is very famous, probably many of you will know, and actually is US Airway actually merge it, okay? And it's approved. Of course, you want to know actually the government is doing right or not, right? So let's look at the case, okay? This case is very simple. Look at the price, 6 years before the merge and 6 years after merge. They look at all the flight tickets. It's a huge data, 15 gigabytes of data, and look at the price of different ticket they sold, okay? And I don't want to go into detail, okay? And let's look at this diagram. This tells you the answer in the average. So the untreated and treated is very simple. Treated are the company, American Airlines and US Airways. They merge together, right? So the merge is the treatment. And untreated is other company like Delta, like Southwest Airline, this kind of outside that thing, okay? Look at the price, it's the lot price, okay? The lot price is very similar before, right? You can see. And after the merge, in fact, other firms actually increase, right? 6 years apart, right? Inflation, reasonable, increase price. And actually remain the same, right? So if you really look at this, right? You look at this, look at control. Look at this, the merge actually doesn't say anything, right? Seems the price the same, right? Maybe, right? But look at how other people are doing, okay? And actually look at difference, which means the merge is very efficient, right? The merge is actually make the firm is very efficient, right? So that is what we conclude from this diagram. Okay? Of course, they run the regression, and you look at data. That's how you do the data, right? When you run regression, merge or not, look at the efficiency is 80%. Okay, and when you do DID, it's very important. People look at heterogeneous effect, look at where the effect they are. So you separate the market into small and big. Turn out to be it's not the large, small market that matter. It's a large market. They save a lot of costs. It makes sense because large market have many planes. When they combine together, then can save a lot, right? Because you can have fewer planes and more efficient allocate, right? So that tells a lot of the story. So that's when you do the ID, right? You may attempt to end here, right? Sometimes you want to separate. Same as what you do prediction, right? You run your regression, you do the project, you may look at all the data. You get one thing, maybe it's over. No, it's not over yet. You may want to say, I separate data into different segments, and you run the regression or you run the machine learning, then may give you a different thing, right? Of course, if you do random forest or do regression trees may already have done that. If you run regression, you want to separate them, all right? Or you actually may require different regression tree in different area, right? Then that will be helpful, okay? Okay, and one very important thing when you run this DID, okay, which often we use, as I said, is what we call parallel trend assumption. It's saying that because we are comparing US Airway and American Airlines to other company, right? Before they merge and after they merge. It must be the case that we think that the merge, if they merge or not, they should go in the same direction, right? Because we use other airline as a counterfactual. What if they do not merge, right? Then the control group and the treatment group should be very similar. They should go in a similar direction if the merge is not there, right? Because we consider other airline as a parallel universe for the company that merge. So you want to draw a graph of the price before they merge here, right? This is to separate them. Is the green one is the treated market, right? Because when they merge, this is the market they overlap. This is the market they don't overlap, right? They want to see if they're related, right? And it seems that they go to the same direction, right? And so it seems to be the merging is using DID is a good one, right? But do note that this can never be proved. We can just convince people that this is the case, right? Because they're not the same thing, right? Another experiment. If the random aside, it's okay, right? Because maybe why US Airway buy American Airline? Maybe because it's endogenous, right? Because I think I can save a lot of cost that I merge, right? So that is a problem that not easy to answer, but that's the part that you have to show this is the case. Okay. Again, you have to include the confounder, right? To make sure that it's okay. Now, this is a DID. The very last, I want to very briefly mention panel data. Okay, I don't go to the detail. Just mention one equation because to go to this is very complicated. But what I want to say, why I want to explain in this kind of model panel data. Okay. In this equation, because that would be suffix to explain everything there, based on this equation. Okay. So panel data is we have different individual, we observe it all the time. So why does it help to understand the variation in X actually to Y? Okay. One of the main reasons that we worry about the causality is there can be the case that individuals are different, right? So basically in this case it's not the X drive this one, it's rather the alpha, right? Individual characteristic, when to isolate it, it's heterogeneous individual treatment effect, right? And how can we solve this kind of problem? Okay, is what we call, one of the things that we do is called first difference. Okay, instead of running this, suppose the data is like this. Okay, you have two periods of the data. So you have y I period 1, right, is alpha 1 beta I1, right? Your period 2 data, I2 alpha 1 beta xi2, right? So period 1, you observe xi1 and xi1, right? Because individual I, right? Period 2 the same. So the question is to take out alpha. Okay, is individual characteristic. So how do we do that? Is we call first difference, is to consider not random regression y and x. Rather, you take the difference yi, which is this minus this. Okay, and when you run this to the delta xi, okay, which is this minus this. Then when we run this regression, alpha 1 is gone. Right? Instead of looking at the regression, look at the changes of the individual over time. So his fixed effect is gone. Right? So that is like difference, right? The idea. But in that case, we can look at how change in X lead to change in Y. Right? So as long as if you have a big data set, right? If you think the treatment, you control all the confounder there, right? Then you run this regression, that's okay, right? So that's why that's the easiest thing you do, right? Of course, there are still a lot of issues here, but this is the most common thing you have as an IT manager, right? Because you have huge number of data among huge number of people, that is as an IT manager, panel data regression is the thing we do, right? Of course, how to do panel data regression is a very deep subject. I mean, usually you need 1 or 2 semesters to master it. Okay, I just mentioned it. In case you want to go further, there are other courses you can take to do it, because I mean, this class is a review and some introduction of statistics, right? I can't do justice on the big subject matter here. Okay, so I guess I just end here because I don't want to go into more detail, but I guess this class I mentioned a lot of terms, but I hope I don't go to a lot of details, but I hope you know these terms, then help you to, go to the Wikipedia, go to the website, and then or go to the ChatGPT, you know what to search, right? Because it's hard to search what you know, we don't know, right? Because you don't know the keyword, the computer can't tell you easily, right? But you know there's some term there. Hopefully that would help you to go further, right? And there's a textbook there, you can read them. They have a very good introduction to the subject we mentioned, right? But because of time, I can't really go into every single detail here. But I hope, as a matter of fact, I mean, we know how to handle this. And but I hope the main thing you learn from this class, right, as a conclusion, right, is I guess many of you would forget what we cover, right? That is normal because you return it to your teacher, right? But I guess the main thing is like you learn how to clean the data, how you run the regression, how you apply the machine learning approach, right? How to read the Python output, how to interpret that, and that will be important, right? Because many of the time when you learn statistics, you actually don't really work on the data, right? That's why I force you in every assignment, you have to write the code, okay? And your project, you look for the data, you clean it up, and write a report and present it, and that's the most important, okay? For the quiz, the quiz and the test, right? Just want you to see how well you're doing, just for grading, right? But the main thing is for this class is you know how to write code, right? Either with help with my slides or with the AI, right? That we learn, right? Because it's actually the skill that you need to work it out, right? For the final exam, right? Basically, the long question, right? I give the code, give the output, how to use it. It is the part that you need in the practice. I hope that the course is designed to the practical. Of course, you can let me know how I can improve by emailing me, or you can do it in the next class. We'll do CTE there. You will tell me how well I'm doing, and I hope you learn quite a bit in the class. I hope you find it useful. And since I have been overtime many times in the past, so I guess it's okay. I let you go 5 minutes earlier today. So if any question, I will stay around to answer you may have. And then good luck to your presentation, to your exam, and also good luck to your other class, which I know will be very challenging. So thank you very much. I will see you next week.